Hello! Now we're going to be finding the domains of these four functions I have up here. F of x, g of x, h of x, and w of x. Okay? And to do so, I'm going to have to drink me some of this water from this H2O. It's tasty dihydrogen monoxide. Anyways, the domain of a mathematical function is the values you can put inside of it that doesn't produce some output error. Such an output error could be maybe you get an imaginary number as a result. Another output error could be maybe you're dividing by 0. Another output error could be maybe you're getting an imaginary number and you're dividing by 0. So let's try and avoid those two things. We're going to try and avoid dividing by 0 and avoid end up getting a complex number involved with our situation. So let's just create some type of wall here. Here's f of x is equal to x cubed minus a 2x. What is the domain of this guy? Well, are there any numbers that we can plug in for x that cause us to divide by 0? No. I can plug in any number here and I'm not dividing by 0 because there's no x in the denominator. This is actually all over 1. So there's no division by 0. Is there any square roots involved? Or where we might get a complex number getting involved? No, there's not. I don't see any square roots there. So the domain is actually all real numbers. Negative infinity to infinity. Come on, Professor Niazi. That one was too easy. Let's kick it up a notch. Let's go to g of x. Our g of x, I have involved, this is a 2x minus a 1 all over x squared minus a 2x plus a 1. What about this guy? Can we get complex numbers? Well, no, I don't see a square root. I don't see a radical there, so I don't foresee us getting a complex number. But I do see x's in the denominator, do I not? And if I were a betting man, I realize that there's some values for x that I can choose that result in this whole denominator being equal to 0. Let's see what values those are so that we can avoid picking those values in our domain, because the domain is the set of values that work. It excludes those values that do not work. So let's find those values that do not work and exclude them from our domain. We got to set this equal to 0 because we want to find the naughty values. Okay? So we notice that x squared minus 2x plus 1 can be factored into x minus 1 times an x minus 1. Is that not right? Yeah. X squared minus an x plus 1. This is equal to x squared minus a 2x plus a 1. Check. This is correct. So x minus 1 and x minus 1 are set equal to 0 separately. They both result in x being equal to positive 1. So when x is positive 1, that means we would be dividing by 0. Whenever we pick x to be a positive 1, this whole thing becomes a 0, and then we're dividing by 0, and that's not allowed. But every other number that we pick is okay. So our domain here, you guessed it, it's all numbers but that pesky number 1. So we'll union. It's negative infinity to 1, union 1 to positive infinity. Okay? Let me clear up some real estate here. And we'll do these other two functions. Okay? Now let's do h of x. H of x is equivalent to the square root of 3x plus 2. I see a square root. That means we might be taking the square root of a negative number. Just think about it. If I pick x to be negative 1, then I would get negative 3 plus a 2. That's the square root of negative 1. Not good. Square root of negative 1. Not good, because then we'll get I. Now, the way to find what the domain is to say, well, since what's on the inside of the radical, it can't go below 0, because then it becomes negative. but it can equal 0 because the square root of 0 is still 0. That's not complex. We'll say 3x plus 2. We want to set up the inequality that this is greater than or equal to 0. And find from which values of x adheres to this constraint. So that's 3x is greater than or equal to negative 2. I'll divide both sides by 3. So I get x is greater than or equal to negative 2 over 3. Right here. So it's the values of x that are at negative 2/3 and greater. Okay? So the way we denote that is we put a bracket negative 2/3 and greater, like that. Okay? That's the domain. Last but not least, let's do w of x. W of x is x plus a 1 divided by the square root of 2x minus a 1. Notice that in this case, we not only have to worry about taking the square root of a negative number, we also have to worry about dividing by 0. So now, what's on the inside of this radical has to be strictly greater than 0. Unlike here, where it was greater than or equal to, because it was okay for it to be 0 there, because it's in the numerator. Here it cannot be 0 because it's in the denominator. So this is strictly greater than 0. Note that difference. So then 2x is greater than 1, divided by 2 both sides, I get x is greater than 1/2. So the domain is all the values of x greater than 1/2. So that's your domain right there. Now, you are an expert at finding domains of various functions.